Hello all, good evening. Am I audible? Please let me know in the chat. Yes, yeah. Before starting the session, I would like to tell you all that for all Vignan students who join in the class, you will be having attendance for today's class, and the link for attendance form will be shared randomly at any particular time by your college management only. So even I don't know when they will share the link. They will share the link in comment section. So make sure you all be attentive in the class and listen class from starting to ending so that you will not miss your attendance also. And as today's topic is on uh, DP on matrix sign multiplication, it is a hard DP problem. So to understand the problem, you need to stay from starting to ending of the class. If you miss any part of the class, you will not be able to understand the problem. So make sure to stay in the class till end. Before entering into the problem, like partition DB, I would first like to give you idea about like how to know the particular problem belongs to partition DB, like what partition DB is actually. You are given a problem, and that particular problem can be solved in multiple ways. And in that, if they ask you to find the optimal way for solving that particular problem, then you can understand that the given problem can be solved using partition DB. For example, here I will give a basic example. If you are given a addition or multiplication like 1 plus 2 plus 3 plus 4 into 5, this particular thing, this particular problem can be solved by using associative property for multiplication. Like to solve this problem, you can either sum up everything first and then you can multiply it with 5. Like 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10. 10 into 5, which is equals to 50. Or else you have one more way to solve this problem, which is 1 into 5, 5 plus 2 into 5, 10 plus 3 into 5, 15 plus 4 into 5, 20. And again 5 plus 15, 20, 20 plus 20, 40, 40 plus 10, that is equals to 50. In both cases, we got same answer, which is 50. But when we see in second case, we perform more number of operations. That is, we applied multiplication with 1, 2, 3, 4, and then we added up the answers that we got. Here, so this is taking a bit more operations compared to the previous one. In first case one, we have just added up everything and then multiplied it with 5, which is easier one. But in second case, we multiplied everything separately and then we done sum, which is taking us more time. So here we can see the difference clearly. The answer which we get in the end is same, but based on the way which we are choosing to solve it is defining the complexity of problem. Here the second case it became more complex. Did you get what I'm saying? Please reply me in comments. In comments, please mention like either method one is best or method two is best. Write down in comment section which method is best, method one or method two. The session should be interactive, then only we can understand that you are listening to the class. Here, as I already told you definition while explaining the problem, I would like to once again tell you the clear definition, like where we will use the partition DB, so that you can easily find out when to use it when you see the problems in exam. Like whenever you need to find answer to a large problem and it has multiple ways to solve it, and instead of having multiple ways, they were asking you to find the best way to solve the problem. In that case, you need to use partition DB. Just a minute, guys. I'm trying to see the comment section. Are there any comments? Stay in the class till the end, because as I said, you need to fill the attendance form, which will be shared randomly, and the attendance form should be filled only by Vignan students. And you will be having exam after this session from 8:30 to 9:30. For all the Vignan students who are attending the live, you will be having exam from 8:30 to 9:30. Just a minute, guys. I'm unable to. Yeah, have it. Then why we are unable to. Yeah, okay, guys. I'm able to see the live. As I said, when you have a larger problem and that problem has multiple ways to solve it, and you are asked to find the best way to solve it, then you need to think about the partition DB approach. For this particular matrix multiplication, we will see why we are using this approach. First of all, we will take two matrices and then we will understand the situation. Here are the two matrices, 1, 2, 3, 4, which is 2 cross 2. And here is the second matrix, 1, 2, which is 2 cross 1. This is first matrix, and here I am writing the matrix 1, 2, 3, 4, and 1 cross 1. This is second matrix. In these both, is matrix multiplication possible for both, or just possible for first one, or possible for only second one? Write down in the comments for which it is possible. Here, when we see the first case, for multiplying first matrix, can this be multiplied or not? To know whether two matrices can be multiplied or not, you need to have basic understanding of math that you already studied in your first year, which is the number of columns in the first matrix must be same as number of rows in the second matrix. Then only two matrices can be multiplied. Voice is not clearly audible. Like one comment is saying that voice is not clearly audible. Please others, let me know, is my voice clearly audible or not? Yeah, for first one it is possible, and to become possible, we need to have number of columns in the first matrix same as number of rows in the second matrix. Then only it is possible to multiply. In In second case, we have 2 cross 2, but here 1 cross 1. As this 2 and 1 are not same, in second case, it is not possible to multiply. Here, when it is possible to multiply also, we will be having multiple ways to solve the problem. We will see what are those multiple ways. For example, if we have three matrices as matrix A, B, and C. To multiply these three matrices, matrix A, B, C, we are having multiple ways. Like we can multiply matrix A into matrix B into matrix C. Or else we can also multiply it like first matrix A into B, then we can multiply this one with matrix C. We have these two possible ways. First these matrix, we will see the answer and we will see how we are multiplying it. For people who don't know or forgot how we will multiply matrices, please listen here. To multiply this matrix, first we will multiply first row with first column, which is 1 into 1 plus 2 into 2. And here before, like you need to even know this one, right? Here to see whether it is possible or not, we see that if it is 2 cross 2 and 2 cross 1, it is possible because number of columns in first matrix is equal to number of rows in second matrix. And to know the number of columns in resulting matrix, that will be number of rows in first matrix into number of columns in second matrix. Here it is 2 cross 1. Here which is 2 cross 1. 2 cross 1 means for first row, when we multiply first row with first column, 1 into 1 plus 2 into 2. And for second row, when we multiply it, 3 into 1 plus 4 into 2, which gives us answer as 1 into 1, 1 plus 2 into 2, 4. 1 plus 4, it is 5. And here 3 plus 8, which is 11. This is 2 cross 1. And here when we calculate number of multiplications that we have done, that is equals to 1 plus 2 plus 3 plus 4, which is totally 4 multiplications. Here, to solve this particular problem, we have done totally 4 multiplications. There is a way to find total number of multiplications that we have done. Here, we will see formula to how to find total number of multiplications that we have done to solve the problem without calculating manually. As here it is just a 2 cross 2 and 2 cross 1 matrix, we calculated manually the number of calculations. But for bigger matrices, when we multiply matrices of double digit rows and double digit columns, we will not be able to calculate number of operations manually. So here, if you observe this carefully, answer is since this is 2 from here into the 2 which we have in common both into number of columns matrix, that is 1. I 2 into 2 into 1, that is equals to 4. Here if you simply see, this is, we can easily observe that these are number of operations that we performed even by calculating manually. For further problems, when we see, the calculation will not be this much simple. So at there, this formula will help us. Number of calculation formula. Okay. Let's see what will happen when we multiply 3 matrices, so that you will understand a bit more clearly about that particular formula. When we have matrix A, B, C, and we take matrix A as particularly like number of rows and column, some random number we will take it as some 10 cross 20, and for matrix B will take it as 20 into 11, and for matrix C we will take it as some 11 into 15. Yeah. When we try to multiply these three matrices A, B, C, we will see what happens. Here, number of possible ways to multiply these matrices are: first I can take matrix A, then I can multiply it with BC, or else I can take first matrix AB and I can multiply it with C. There are two possible ways. In two possible ways, we will calculate number of operations that we're going to perform with help of this formula that we saw earlier. Here, for matrix A, as matrix A is a single one, here we will not be having any multiplication, like any operations will not be needed for this particular one. For matrix B, and we will calculate for matrix B and see how many operations are needed. To solve matrix B and C, like this matrix alone is 10 cross 20, and here we will see what will happen for this one. When we multiply matrix B and matrix C, that is like we are multiplying 20 cross 11 with 11 by 15. Here, when we multiply these two, as we seen earlier, total number of operations will be 20 into 11 into 15. That is 20 into 11 into 15, which is 3,300. To solve this one, it is 3,300. And the resulting matrix will be of size 20 cross 15. So, when we multiply these two, again it will be, again number of multiplications will be 10 into 20 into 15. That is 3,000. So total number of operations to solve this will be 6,300 if we solve in this way. And we will see what happens if we solve in this way, like first A, B and then C. When we first solve A, B, to solve A and B, number of operations will be, when you observe this here, number of operations will be 10 into 20 into 11. That is equals to 2,200. And to solve again AB with C, when we solve A and B, the resulting answer will have this 20 and this 20 will be cancelled, 10 cross 11, and C has 11 cross 15. So to multiply AB, the result AB with C, we need 10 into 11 into 15 operations. That is equals to 1650. So when we sum up these, we will get 3850. But here we got, in this case we got 6300. In this case we got just 3850. So there is a huge number of difference between the operations that we are performing when we have just three matrices, and that too with just a size, with just number of rows of like 10, 20, 20, 11, 11, 15. But what if we have very huge number of rows and columns, like 100 rows and 100 columns, or else 100 rows and 500 columns? In that case, based on the multiplication order which we are choosing, there will be huge difference in time that is taken to calculate the answer. So, to avoid this kind of problem, we have come up with this approach of partition DB. Like, we will see what is the most optimal way to solve the problem. Like, in which way we are taking less number of operations, like in which way the cost to solve the problem will be less. By analyzing this, we will try to solve the problem. So, I hope you understood the difference, like why order actually matters. Here in first case, when we try to multiply A with the product of B, C, the total number of calculations that we are doing is going to around 6300. In second case, when we are trying to multiply the calculations, like when we first try to multiply AB and then multiply it with C, in that case, the number of operations are very less compared to the first one, which are 3850. So, based on the order which you are choosing also, we are having huge number of difference in the calculation, the time taken to calculate the solution. So, here even the order matters in some problems. In those problems where we have multiple ways to solve a problem, and they were asking you to find the best one where we are taking least amount of time, there we will be coming up with the partition DP kind of problem solving. Here, if I need to explain it with the example of an array, here if we have an array of in this way, why we are calling it partition DB, in the sense like if we have an array in this way, just a minute. Yeah, guys, just a minute. I'm sharing the link with students. Like some of students did not get the link, so they were asking for link. I'm sharing it with everyone. Yeah, guys, we'll continue. Here, when we are given an array, if they ask us to make the partitions of this array, there are multiple ways to create partition. Like we can make this kind of two partitions, this one and this one, or else we can make in this way. This is one partition, and again this is one partition. Again, this particular partition internally can have multiple partitions, like in this way. So the flow of creating partitions will continue, and in the end, we will calculate answer by summing up all those by taking the minimum answer which we are getting. And here I hope you understood the way in which we are multiplying matrices and how we are getting the number of calculations, like number of operations that we are performing. Number of operations are simply the number of rows in first matrix into the common number which we have, like number of columns in the first matrix into number of columns in second matrix. For example, if you have a matrix like 1, 2, 3, 1, and a matrix as 2 and 3, this is 2 cross 2 and this is 2 cross 1. In comment section, please let me know how many operations we need to perform. In comment section, please type the number of operations that we need to perform to solve this problem. In comment section, type the number of operations that we need to perform to solve this problem. 4. Yeah, 4. Yes. Which first matrix or number of rows in second matrix? The final number which we have. Yeah, guys. Here, now let's see how they will give question to you. Then you will understand, or else I will first help you to come up with the formula for this only. So further, when you try to calculate, when we try to write code, it will be easier for you. Here, if I take 4 matrices, or else if I take 3 matrices, just a minute, we will derive the formula for calculating it. I told you formula, right? We'll try to derive it. Yeah. Here, if you have 3 matrices, A1, A2, A3, with number of columns as 2, 3, 3, 4, and 4, 2. Here we will see what are the ways in which we can multiply these 3 matrices, and we will try to observe the formula from this. Here, as I told, it is matrix A1 into matrix A2 into matrix A3, and I told you the number of rows and columns in this are 2, 3, here 3, 4, here 4, 2, and when we try to multiply it, we have 2 options. That is, first we can multiply A1 into A2, and then we can multiply this one with A3, or else we can choose the second way, which is we can first take A1 as it is, and then we can solve A2 into A3. Here, when we observe this one, here for A2, for A1 itself it has 2 and 3. For A2 we have 3 comma 4. For A3 we have 4 comma 2. For A1 we have 2, 3. And for A2 we have 3 by 4. For A3 we have 4 by 2. These are number of rows and columns for each particular matrix. When we observe A3 at here, to solve A3, the number of operations which are required are how many? Just try to think, guys. Here, if we wanted to get the resultant matrix of A3, is there any number of operations that we need to perform? No. We don't need to perform any operations as A3 is just a single matrix. I.e., we have A3 as a single matrix, that is 3 comma 3, third matrix. We have A3 as third matrix. To solve A3, we don't need any operations, which is 0. A3, the number of operations required are 0. So to solve A3, the number of operations required are 0. Is it clear? You will see the number of operations required to solve these two. To solve these two, number of operations are required are 2 into, like this is C, we are calculating 1 comma 2. For solving, number of calculations required to solve 1 comma 2. Here number of calculations required to solve is third comma third matrix. Here number of calculations required to solve first comma second matrix together is 2 into 3, 6, 6 into 4, nothing but 24. So here we need 24 operations. And after solving this one, we will get a resulting matrix. And the resultant matrix size will be here 2 comma 4. And we need to solve this one with A3. A3 size is 4 comma 2. So here, for solving these two, the number of operations that we need to perform will be 2 into 4 into 2, which is 2 into 4, 8, and 8 into 2, that is 16. So total 16 number of operations are required to solve these two. When we sum up all these, it gives us 24 plus that is equals to 40. When we observe it clearly, how we got this 40? This is first number of calculations for C, 1 comma 2. Calculations for solving 1 and 2. Then calculations for solving third below, third as this. And then calculations, but here 16. How we got 16? First we initially solved this one, like first bracket we solved initially, and then we solved first bracket with second one. By using this the answer into the initial matrix, we got this 16. So we can represent this 16 as answer into our third answer. In that way we can think, which is 2 into 4 into 2, this one. And here quickly for second one. For second one, here the number of operations required are 0. Here number of operations required are 3 into 4 operations are required. And A1 with the resultant matrix that we got, which has 3 cross 2. So we need 2 into 3 into 2 number of operations. So in total we need 0 plus 24 plus 2 into 3 into 2. That equals to 3 to the 6, 6 to the 12. 24 plus 12, 36. So here the best way to solve this will be in second case, which is 36, least number of operations. This is what we need to return in the question given to us. Here when we observe, we are following a recursive way. How we will know that we are using recursion to solve this problem? This problem here, when we have 3, we are not able to see in big picture. But if we have something like A, B, C, D, E, F, G, H and all, then to solve this, we will be having multiple ways. First, we will can just take single A and then take all this. We have one way to solve this is A into B, C, D, E, F, G, H. Other way to solve this is using AB into again C, D, E, F, G, H. And other way will be A, B, C and so on. And again at here, we have multiple ways to solve this problem, which are A will be same. Again at here, we may take just B once, and by taking B, we may take separately for C, D, E, F, G, H. This. Again, this may have multiple ways of solving. Here, when you observe this C, D, E, F, G, here we are calculating. Just a minute, guys. When you observe this kind of pre-representation, like breaking down into subparts, and in the end, when we are returning, like what we will be doing next, we will be calculating for again this one separately. For C, we may take separately, and we may take D, E, F, G, H separately. And by taking all these, what we will be doing in the end, we will calculate the minimum answer, like minimum operations in the below tree, and we will return those minimum operations to the above. And from these two, again, we will return the minimum one. From these two, we will be returning the minimum operations. In the end, when we have just a single matrix, what will be the base case? Base case, when we have single matrix, the number of operations will be mentioned in the chart. When we have single matrix, the number of operations that we need to solve will be how many? Write down in the chart. That will be 0. As we have single element in base case, number of operations required will be 0. So we'll be returning 0 when we reach single element in the base case. Until reaching base case, we will be splitting it in this way only. I hope you got my point. Because we will be splitting the matrix. I did not see anyone adding in chart for this one for that we need to perform when we have single matrix. Base case. What will be the number of operations that we need to perform when we have just a single matrix? Write down in the chart, guys. It is 0. Just wanted to know how many of you are attentively listening to the class. So write down in the chart. Yeah, 0, 0. And I hope you all understood how we are calculating number of operations. Because I explained with multiple examples to calculate number of operations that we are doing. So by now you should be clear with when multiplication is possible and how to calculate the number of operations that we are multiplying a matrix. You should be clear with these two things by now. And even you should understand that how we are splitting the matrix. Like we are breaking down the matrix into parts. But first we are calculating for the initial matrix and then we are calculating for the resultant answer. Yeah, correct. Arun, Manadeep. Yeah, your answers are correct. We will see how they will ask in question, like what will be the format in which they will ask in question. I will to display the question to you. In question, they will give you an array. In that, they will give you the, see, given an array which represents the dimensions of sequence of matrices, where ith matrix has the dimensions array of I minus 1 index into array of I. Sir, screen is blur. Okay. Guys. I can say it is a bit blur. Okay, yeah, it is okay now. Given an array, in that array, they will be giving you the dimensions of the sequence of matrices. Like ith matrix will have array of I minus 1 index into array of I index 1, where I is greater than 1. I will explain you this question in a simple, most simple way. They will given an array, like the array is in this way. You can take the array like this. Yeah. If this is our array with 10, 20, 30, 40, and 50, the array index will be starting from 0. You all know that 0, 1, 2, 3, 4. And here, what is the size of array? Size of array equal to 5. But using this, how many matrices can we get? You try to understand, like if they give an array of size 5, how many matrices we will be having from that? Like how many matrices dimensions we may have in that? If array is of size n, number of matrices will be n minus 1. Here you will see why it is in that way. Because initially if you take 0, and what are the how many numbers we need to construct a matrix? We need number of rows and number of columns. Yeah, Sunita, you are right, n minus 1. Correct. It is to build a matrix, we need rows and columns. So we need two variables to build a matrix. We need rows and columns. Here, if we start from here, with just 10 alone, we cannot build a matrix. We need these two values to build one matrix. And here, with these two values, we can build one more matrix. Here, with these two, we can build one more matrix. With these two, we can build one more matrix, which is 1, 2, 3, 4. When they give an array of size 5, we can build 5 matrices using it. And here, the size of that matrices will be in this way. For A, it will be 10 cross 20. For B, it will be 20 cross 30. For C, it will be 30 by 40. For D, we will be having 40. I hope you understood. If they give an array of size 5, from that array of size 5, we will be having 4 matrices, which is n minus 1. If they give array of size n, we will be having the dimensions of n minus 1 matrices in the array. If you observe this, for first one, for what are the dimensions of first two? Array of 0 into array of 1. For second, it is array of 1 into array of 2. So, for third, it is array of 2 into array of 3. If you observe here, for 1 it is 0 and 1. For 2 it is 1 and 2. For 3 it is 2 and 3. If you observe all this, from this we can understand that for ith matrix, the dimensions will be a of I minus 1 into a of I. You can understand this by seeing the above derivations. I hope now you understood this one. How we are writing the dimensions from the given array. In the question also they will be giving the array in this way only. From this array you should be able to get the dimensions, because what is our motto? Our motto is to find the minimum number of operations that we can do so that we can multiply the matrix. First, to calculate the minimum number of operations, we need the dimensions of array. We have seen that to calculate minimum number of operations initially, we need these dimensions. But they will not give these dimensions directly for us. They will give these dimensions in an array. When they give these dimensions in an array, here we seen how we can get the dimensions from the array. If you understand these two things, we can move to the next step, like trying to solve the problem. Write in the comment section, did you understand from an array how we can get the dimensions of matrices? Yes or no? Write in comment section. Yes sir, Arun, yes. Still remaining Manadeep, Sunita, Lavanya, Taruni Krishna, remaining all. Yes. Okay. Everyone understood then. Yeah. Now we will see how we are splitting it. Like we have imagined, like previously we seen manually, like we are doing with our eyes, like we are splitting by seeing one by one. Here now we will see by using pointers, like by using I and J, we will see how we can split it. Here if we have four matrices as A, B, C, D. Okay, sorry. This is on. Yeah. If we have four matrices A, B, C, D here, for these four matrices, we will think them as I and J. We are having two pointers I and J. What are all the ways in which we can split? If we think we are starting from I, we can take entirely like I alone and from I plus 1 to J completely. This one we can take. But one possible way, just A we will take and everything from B to C we will be taking. That is one possible way. And other possible ways are taking A, B and C, D. Or else taking A and B, C, D. Taking A, B and C, D together. There are multiple ways of taking it. Yeah. When we take in this way, we will try to represent it with I and J. Here, our I value is here I and this is J. Like this is I is the starting index, J is ending index. Here I is starting index and J is ending index. I, J, I and J, I, J. Here I and J. So we need to try all the partitions. As I said, in this case where I equal to J, that means we have only single element. When we have single element, what we will be returning? We will be returning 0. When I equal to J. Just observe it carefully. We are assuming I as starting index and J as ending index, and we are splitting the given matrices using I and J indices. And when I observe it here, when I have just single A, my I and J both are pointing towards A only. When I have single D, here also my I and J are pointing towards single value. So when I equal to j, I have a single matrix. When I have single matrix, I already know that number of operations will be 0. So this will be my base case. When I equal to j, I will be returning 0 because number of operations will be 0. I hope you got the point that I am saying. Yeah. Here we will start with an element and we will iterate through entire array. We will iterate through entire block. We will try all the partitions. Like we will run a loop. We will take first I and we are running the loop over the remaining elements from I to the remaining one. And we are again taking the loop, like this one will be the number constant, and for this again we will be taking one more loop. For this we will be taking a loop. So when we have single element, we will return answer directly, and when we have multiple elements to split again, we will be taking loop until where our loop will run. Our loop will run from here. If we take numbers like 10, 20, 30, 40, 50, the array that we have previously. So the array, the same array that I took here, I am taking it here. Here my I is initially at here, and I am assuming this as matrix A, B, C, D, and this has J. Here, initially my I will go from I to J minus 1. Till here my I will go. Or else if I start from here, my I will go till here. Because for when we have single element, as I said you, we no need of calculating for single. When we have single matrix, it will be 0. So what we'll be doing, we'll be starting from I and we'll be going till j minus 1. Because as j is already ending 1, there we'll be having 0 calculations only. So the answer will be in this way. From in first iteration, we'll be going from I to k, and in next iteration, we'll be going from k plus 1 to j. I will explain you this a bit clearly here. What we're actually doing. As I said, we will be doing this in a loop. When we are doing this in a loop, our starting value is I. We will start from I. Then we will iterate I plus 1, I plus 2, I plus 3. But in one iteration, we will not do. For first iteration, we will be taking I alone and we will be taking all these 3. Then in second iteration, we may take these 2 together and these 2 together. In third iteration, we may take it like this 2 and this 1. So inside also, we will be having multiple iterations. When I take only this one, it will be from, if I take only this one, my k will be at here. From I to k and again from k plus 1 to j. If I take till here, my k will be at here. From I to k and again from k plus 1 to j. In this way, I will be performing the operations in this way. I will be calculating from I to k and again from k plus 1 to j. This and from both, I will be taking the minimum answer. I will be returning the minimum number of steps or minimum number of operations that need to be done. I hope you at least got an idea. Let me know in the comment section, did you understood how am I splitting? Write down yes if you understood and no if you did not understand in comment section. Guys, write down in comment section. If you understand this, it is almost you understood the core logic, then we can see one more formula. Like we can see how we will be calculating in the code. We will be deriving a formula to calculate in the code, and then we will be going to coding part. Write down in comment section, everyone. Yes, sir. Yes, sir. Still, I got only 2 yes responses remaining. Everyone write down either yes or no. If you write no, I will be explaining one more time, and then after that we can go to coding part. If it is yes, I will be going to coding part after deriving the logic. Yeah, okay, then you got it. Here, from these two things, we can derive the formula of how we will be calculating it. If you observe this, what I said, I will be taking minimum of again these two, right? We will be writing formula, guys. Just a minute. Yeah, guys. Here, we'll try to write formula. When we wanted to do calculations for I comma j, what we will be doing, we will be taking minimum of calculations till I comma k plus calculations from k plus 1 till j. Is this clear? I think till here it will be so much clear for you all. Till here it will be clear. And the next step is also crucial. Just focus and try to understand the next one. Here I have just wrote the above one in the below. I just tagged it as minimum. And for this we'll be adding one more thing also. Here we are seeing the number of operations that we need to do till I to k. Observe carefully, guys. This is the main point. If I take my k here, I need to, these two are showing us that we are splitting till here and from here to here. And if I take my k here, we are splitting from here to here and then here to here. By using these two, we will be getting calculations only for the splitting part. But after splitting, we will be calculating internally. Again, we need to merge it up. Previously, for ABC, for A we have 0. For B and C, we will be having separate calculation. And for that, when we get that separate, multiplying that A with BC. When we multiply A with BC, together we will be having one more answer. And in the end, we will add that 0 plus the separate answer that we got plus this answer. So, our answer will consist of three parts: the left partition, right partition, and the number of calculations that we are doing while multiplying left partition into right partition. Hope you got it. This is the key thing that you need to understand, students. Here I wrote two operations, that is number of operations for left partition and right partition I wrote, along with number of partitions for left and right, along with number of partitions for left partition and right partition. We need to even add the calculations that we will get when we multiply the left and right partition after finding the answer. So for that again it will be some like I am taking and replacing it with d. I minus 1 into d, k into dj or something. I am writing it in this way. And k value. K value will be always from one. I and k value will be greater than equal to I and less than equal to j. This formula I will explain to you guys. Just wait. Have we got this one? Here, when we are splitting, our k will start from 1, at least 1. When we are at here, our k value, I'll just zoom out this system. Yeah, now we will be understanding it here. When we are at here, what are the possible values for our k? My k can be here, my k can be here, my k can be here. My k can be equal to I, or my k can be greater than I. That's it, right? I hope you are understanding. When I split till here, my k cannot be here. I cannot split backwards. I can split from in between I and j. So my k should be greater than I, and my k should be less than j. I can split till here. From here, I can split till here. Ending, at least I need to leave one, right? That is why I'm not taking equal to j. If I take equal to j, then I will get the same answer. It will be like k K will be equal to J means again I will be having same answer, so I am not taking equal to K. If it is at here, it will be this one and this one. If it is at here, this one and this one. So my K can be greater than equal to Y, less than J. If you got this, write down in the comment section. That is the reason for writing K greater than equal to I and less than J. For this one, for this di minus 1 into di minus K, this one I will be explaining you with the previous example that we took only. Then you will be understanding. Why I wrote multiplying these two, we will be getting a resultant matrix. For that resultant matrix, the multiplication of those three. Yeah. Otherwise, I will be taking a new matrix and I will explain you how I got it. In the previous matrices, when we took matrix A1, A2, and A3, here for this is the same matrix that we have previously. Same one I am taking again for a better understanding. A1, A2, A3 I took previously. For it is 2, 3, 3, 4, and it is 4, 2. When I take A3 separately and these two, the answer that I will be getting is C of 1, 2, that is equal to 24 at here. At here, calculation between third matrix, that will be 0. And afterwards, I will be having a resultant matrix as 2, 4, because these two will be cancelled. I will be having 2, 4 resultant matrix, and next matrix will be 4, 2, which is this A3 matrix. In this, the number of operations which I will be getting is again is 4 and 4, 2 into 4 into 2. And for before one, I will be having 24 plus 0. Here, when you see, this is 24 plus 0 plus 24 plus 0 plus these three values. I have written the same thing here in the formula. Calculation for the left partition, that is these two. Calculation for the right partition, the same as A3. And the calculation for the resultant matrix, I put here I minus 1 to J. I hope you got it. Did you understood how I took it? How I took this? You may feel this problem a bit complicated because this is part of hard DP, but try to listen the lecture again and again, or else try to go through the problem on Geeks for Geeks. I will be solving problem. I will be doing live coding next. At the time, you will be understanding it a bit betterly if I understand it clearly. First, let me know in the comment section with the formula. The formula. Why we took formula in that way? Write down in the comment section, guys. Arun, are you there? Write down in the comment section, everyone. Now you may feel a bit confused, no worries. When we will do coding, you will be understanding it more clearly. Okay, then let's start coding because I need to explain you the recursive answer, then memoization, and then tabulation one in half an hour. As you will be having exam from Vignesh, will be having exam from 8:30 to 9:30. It is already 7:36, so we will start coding. Before going to coding, please let me know if you have any doubts. Just type down in the comment section, guys. Everyone are clear with the theory part and algorithm? Is there any doubts or everyone are clear? Okay. Then I will be going to coding part, guys. Yeah, you are asking why only D minus D, K or D object. Yeah, those are just notations. I wrote it. Those are just notations here. Those are just simple notations. Just I wrote them as by thinking of dimension 0, dimension 1, dimension 2. Those are just notations. So if I take this as dimension 0, dimension 1, dimension 2, dimension 3, like sorry, this is dimension 0, dimension 1, this is dimension 1, this is dimension 2, this is dimension 2, and this is dimension 3. I hope it is clear, right? These are three dimensions that we have. By assuming these three as dimensions, I wrote that in that way. From dimension 0 to dimension j. Which is the previous one where we are splitting it. Here when you observe what we are having here, here we, I will take a different color. Here we split it till this 4 and we are taking this one. Here when you see what is the answer that we got, the answer that we got here is 2 into 4 into 2, which is here this 2 is the first index that I have it here, and this 4 is the k where I am splitting, and this 2 is the j value. If you compare it with the left side one, yeah, if you see, this is I, for example, if I write it here k, this is k where I am splitting, this is j, ending one. When we compare these three values, we are getting I minus 1. Where I am starting, I is at here 3. I is in 3 place, right? I is at here, in the second dimension place. Like D1 place, I will have I. If you imagine this as D0, D1, D2, D3 and all, I is at dimension 1 place. But in answer, what we are taking 2. That is I minus 1th place dimension, this 2 plus this kth position 1 plus the jth position 1. That is why I wrote it in this way. I hope you got it. Karana Krishna, is it clear? Yeah, I think this must be clear as this is a doubt. It must be cleared by now. We will be going to coding part then. Okay, thank you, sir. Okay, you got it clear. Okay, guys. Yes, sir. I'm going to explain you coding part. Then I will be doing coding, guys. This is the same question that we saw previously. Yeah, guys. Before before starting the coding, as we know that this is a recursive problem, even yesterday I said you, is it possible to write recursion in the same method that they have given? Is it possible to write the recursion in the same method that they have given? No, it is not possible because in our case, what is the base case for our recursion? I should be equal to j, then we will be returning 0. But here in the method that they are passing, they are not passing I and j values. So we need to write a separate method which will be suitable for writing our, yeah, it's okay, screen off. You should be getting a screen now. Just wait for a second, wait for a few time, wait for some time. Yeah, right, Ashita. You are able to see the screen now. Here, as I discussed with you earlier, the base case will be when I equal to j, we should return 0. But to write base case, we are not tracking I and j values in the given method. To track I and j values, we need to write separately a method so that we can write the code as per our convenience. For that, I am writing a new method. In that new method, I will take all the variables that I need to write my recursive code. For that new method, I am taking it as static int f. I am taking this new method or function name as f int I, int j, index j, and the array which they are giving to me. I am taking it as a. In this, I need to pass the array which they are giving to me while given the question. Here, int n equal to arr dot length. Yeah. And what I need to return, I need to return the answer that is given by the method that I am writing now. For that, I am passing I and j values. I am passing array to it. And here, our base case is the same thing that we are discussing from that time. I passed j value which was n minus 1 as I shown you previously. N minus 1 and my I value starting at 1 as I shown you earlier. Here, if I equal to j, I should return 0. You all know it, as we already discussed, you all know it. And our goal is to calculate minimum calculations. To calculate a minimum value, we should initialize the variable initially with the most possible number. We should initialize the variable with max. So I am initializing it with integer dot max value. All Vignan students, I think your faculty share attendance form. When you get the attendance form, by that meantime, I will be explaining the problem. You can come back and listen to the problem after filling attendance also. As you will be having exam 8:30, I will try to continue the class. You just check in attendance. You check for attendance from the comment section. And attendance form will not be there for long time. It will be the responses will not be taken for long time. So try to fill it as soon as you get the attendance form in comment section. Min value, I am initializing min value with the integer max value, which is the maximum number possible for an int in Java. So that when I try to find the min value, I will not be missing out any possible integer. Starting from I, as we saw in the algorithm, and our k can go till to find the cost. We saw the formula, that is first we need to calculate cost for the first I till k partition, and I am passing the a, and this one plus the cost that we need for the second partition, that is k plus 1 comma j, and I am passing the array that they have given, and plus, as I said, the calculations that are needed to be performed after getting the resultant value. Now, after solving the first partition and second partition, we need to multiply the first and second partition. At that time, the number of operations will be a of into a of j. I explained a of I minus 1, a of k, and a at jth index. If anyone have doubt in this, you can go back and refer to the cost equal to f of I comma till k index cost from k plus 1 index to j. And I'm taking these three values as I explained in the algorithm. Why I took three values, you should be clear with this. If anyone have doubt with this statement, please you can go to the back. You can just go back and refer it once again. You can refer the video once again. And as I said, we should take the minimum value in the answer that we are getting. That is math dot min of min comma cost. We should take the minimum value of all the answers that we calculated. In the end, we should return the answer, which is return min. That's it, guys. Our code is completed. Code is this much simple. The main logic exists in these two lines only. If you need to understand these two lines, you should go back and read it once again. Students, be ready. You're going to get attendance form. Only Vignan students fill the attendance form. From outside, you don't need to fill the attendance form. Your output and expected output are same. We try to submit it. When we submit it, we will be getting time limit exceeded because this is the brute force one. Out of like 1010 test cases out of 411 test cases, we'll try to optimize it. We try optimizing. We know that we can do memoization when we try to optimize it. And in memoization, I already explained to you yesterday how to convert recursive code into memoization. Just in place where you are calling recursive functions, instead of calling recursive functions directly, just above the recursive function calling, you need to add a if condition and check whether this answer already exists in my DP array. If it already exists in your DP array, you can skip the recursive call and return the answer which you stored in your DP array. And rest everything will be same. So we'll try to convert this answer into the memoization now. To convert it into memoization, we need a DP array. I'm taking an initial. If you are able to converting it into memoization and tabulation is so simple. Memoization is just simple and same to same as recursive code. Just instead of making recursive calls above the recursive call, you need to add an if condition and check if the answer. That's it. If you are able to code 100%, you will be able to write memoization code also. From I equal to 0, I less than n, I plus plus, for in j equal to 0, j less than n, j plus plus. dp of ij, I am initializing it with -1. I hope you all know this basic answer of y. I am initializing it with -1 because in future when I need to differentiate between the answer that I already calculated and the answer that I did not calculate, I will check it with -1. If it is -1, then I did not visited that particular index. That means I don't know the answer for that particular cell. So I will be calculating the answer. Or else if it is not -1, that means I made some change at that particular cell in the 2D array. That means the answer is already stored for that particular iteration or that particular function call. Yeah. Here, along with the array, we need to send the DP array that we recently declared. The function in this matrix multiplication method is completed. The code that we need to write here are completed. Now we'll try to edit the code that we wrote in our custom method that we redesigned. Here, as I said, just above, we will be trying to add an if condition. So just above for loop, I am checking for that particular I and j values. dp of j not equal to -1. Then I already calculated answer for that particular recursive call. So I will be just returning the answer. dp of ij. And here, where else we need to make changes? Everywhere where we are making, because we need to store that function call, right? Here, before making the recursive call, if it is already calculated, I am just returning the answer instead of making recursive call. And in the end, when you are calling the function, just check it here. Here, our for loop will be same. Our cost calculation will be same. But along with the array that they have given, we need to pass the DP array also as we made changes. Here we need to pass DP array. That's it. The function or the code that we need to do in the for loop also completed. Now, instead of returning min directly, we need to store min inside the DP as DP of ij equal to min. We need to just store it and return it. We'll try to see. Cannot find the symbol. Yeah, sorry, I did not accept the DP that I am passing it. If you see, okay, our output and expected output is same, we'll try to submit the code. Yeah, our code is submitted now. Just made few modifications. If you see, in the recursive code, I did not change any logic. In the same recursive code, I just initialize the DP array, and in the DP array, initially I initialize it with -1, and I pass the DP array. Before making the recall here, I check the if the answer is already calculated or not. If answer is already calculated, I am just returning the answer. Or else, I have just added a single min. That's it. You are able to write the DP for the hardest problem. The matrix and multiplication, which is one of the hard problem in DP. Now you are able to solve it. I hope everyone understood how we are solving it. If you are able to write recursive code, it is same to same. Just we are storing the answers in DP and we are able to return it, and the code was submitted also. And now, for people who are confusing, like where we are having overlapping subproblems in this, I will just show you. I previously only showed you that here, and once again I will show you why when we try to write the answer using recursion it got submitted, and using when recursion it is not submitted, and using memoization it got submitted. I will show it to you guys here. Yeah. When we look at it here, here when we see this CDEFG and CDEFG is getting calculated 2 times, and at here only just it is getting calculated 2 times. When we write some other tree and some other answers, it will be getting calculated multiple times. So we are having overlapping subproblems. This CDEFGH and this CDEFGH are getting calculated multiple times. To avoid this multiple times calculation, nothing but to avoid overlapping subproblems, we choose the DP. When we try to submit using recursion, we got TLA. When we tried to write answer using DP memoization, it got submitted. Here you can see the reason for that. I already calculated CDEFG here, and again I am calculating it here. This is just a small matrix multiplication. In this only, I did not even write all the possible segregations or all the possible partitions. I just wrote 3 partitions. In 3 partitions only, it got repeated twice. So if you write all the partitions, it will be repeating so many times. So that is why we are going with DP problem, and the DP problem or memoization problem are submitted. Now we'll look at the tabulation code for that. As we have just 2 minutes of time, like it is already 7:58. I will try to finish the tabulation as soon as possible. You will be having exam at 8:30, guys. Just remember it. We'll try to write code for tabulation. Yeah, guys. We'll finish the tabulation code as soon as possible. You need to write exam from 8:30 to 9:30. All Vignan students, you will be having test from 8:30 to 9:30. I initialize the DP, and then here, before initializing it with -1, as it is tabulation, I just wanted you to understand that for diagonal, nothing but for 1 comma 1. For matrix 1 comma 1, we will be having a number of calculations. What is the number of calculations for 1 comma 1 matrix, for 2 comma 2 matrix, 3 comma 3 index 1? When I comma I or j comma j both are same, like when I equal to j, the answer will be 0. We know that. That is the base case that we have written till now. So first we will be filling base case for the tabulation. In tabulation, every time when we write tabulation, first we will fill base case, then we will start filling the next cases which are dependent on base case. Here the base case is when I equal to j, we will be having 0 calculation. So I am first filling the base case. I plus plus dp of I, nothing but I equal to j, not equal to 0. We have finished base case. After finishing of base case, now we'll try to fill the remaining table. Here for remaining table, I am taking for int len equal to 2, length less than n, len plus plus. I will explain you why I took in this way. Initially, I am taking the number of calculations that we need to do in your WhatsApp, because here link is not visible due to YouTube guidelines. So you can respond to attendance link that posted on your WhatsApp group, guys. Try to fill as soon as possible, because it will not accept responses after some time. So first you go and try to fill the form, and you can come back and listen to the class by going to back. First fill the attendance form, then you can come back to the live again. I am starting my loop from len equal to 2, len less than matrices to start solving my problem. If I have one, then I will not be having any calculation. So I am starting from my len equal to 2. And for int I equal to 1, I less than equal to n minus len I plus plus j equal to, will be taking ending 1, j equal to I plus len minus 1, and I am initializing that answer into my dp of, I am initially storing it with the integer dot max value. And now I will calculate the value. for int k equal to I, k less than j, k plus plus. It is similar to the same logic that we written earlier, but here instead of making recursive call, I am taking answer from my DP array. DP of k plus 1 plus j plus nums of I minus 1 into nums of k into nums of j. Here, this is same as previous one. Previously we call the function for I to k till partition of from I to k and from partition of k plus 1 to j, and then I am multiplying I minus 1 into k minus I minus 1 into kth index 1 into jth index 1. This is same as previous one, and I am storing the answer in my DP array. Method min of DP of ith index, jth index, cost, whichever is our answer. Try to compile it and see. Yeah, there are a few cannot find symbol. And number 13. Just a minute, guys. DP of I and k plus DP of k plus 1 and j plus nums of I minus 1 into nums of k. Sorry, guys, it is not nums, it is ARR. We took array. Here they are passing it as array, so it is array. In the explanation that I said, there I took nums, but here they are passing it as array, so it is error. Yeah, guys, it must be submitted now. It is submitted successfully. That's it. This is the tabulation question. This is the tabulation code. Here, I declared the 2D DP, and initially when I equal to j, I filled it with 0. As we know, 0 condition will be taken, and for number of partitions, we need to at least have two matrices. So I started from n equal to 2 and I went it till less than n. And for I, we already seen the outer I will be from I equal to 1 to I less than equal to n minus n. And for j also we already seen in the explanation. Initially we are storing it with integer max value so that in future when we calculate min, we will not get any problem. Then here similar to the one which we solved earlier, our k will start from I, our k less than equal to j, our k plus plus. For cost, instead of making recursive call, I am taking it from DP and I am multiplying this one. That's it, guys, for today. And our next class will be tomorrow at same time. You can leave the class and just don't forget to fill the attendance form. Next class will be on 23rd at same 6:30 p.m. Nothing but tomorrow. Next class is on 23rd 04/20/26 at 6:30 p.m. You can leave the live, guys. That's it. And your exam timing is 8:30 p.m. to 9:30 p.m. Don't forget to attend the exam. All Vigyan students write down the exam so that you can analyze your ability to solve the problems, whether you are able to understand the class or not.